Hey guys, welcome back to one more video. Progress over the last few weeks. Um, a real quick recap, just 30 seconds. This is the way I used to do Operation 0, and this is the way I did Operator 1. Operator 0 handled pins. This one handles crystals because Operator 1 doesn't have any crystals, and Operator 2 really doesn't have any pins, or Operator 1 rather. 0 pins, 2 crystals. And I needed two kind of different ways of going about making those. This was a traditionally a top-down layer by layer approach, and the crystals was a bottom-up layer by layer approach, but I found that there were limitations on doing it both of those. So when you're making a full layer, the pins become a problem, and you really have to do some fancy footwork. Now I got them to work on this one, but there's a lot of instances where they won't work. So uh, sh- sh- story short-ish is that I went to a quad stacking. Um, this is kind of the next way of doing it, I guess you could say. Um, quick orientation, what I'm doing now is I'm building each individual quad stack. So this is the northeast quad stack, all four layers. This is the northwest, southwest, and then southeast quad stacks. And then they get assembled over here by some clever, well, for me anyways, swapper logic. And pins get broken in a lot of different ways when you try to slice them, stack them, and things like that. If you're not familiar with pins very much, they're one of the most pain in the butt things in the entire game, um, because they drop. And so, what do I mean by that? Well, if you look at an individual quad stack, you're going to find that sometimes the pins don't stay where they were created. And so, what I did is I kind of exhaustively went through and tried to figure out every possible combination of a quad stack that had dropped pins. And I should have rotated that the other way. Um, and this is what I came up with. And this may or may not be all inclusive, but these are the different. If you look, this is a top, second layer. I'm sorry, top layer, third layer, second layer, base. So this is the top, this is the base. So null, 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 pin, null, null, pin, pin, null, pin, 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 shape, etc. Okay, so those are all instances of where a pin has fallen down. And some of these I didn't even think were possible to make in the game until I actually started messing around with it. But all of these are possible to make in game, um, on an individual stack to a quad. But they can't stand alone. Like they have to have like a scaffolding around them. So I don't think you get to see it when no. Anyway, I just made all these so I could quickly go through things. I'll make this available if anybody wants it. If your Make Anything machine is actually a Make Anything machine, it ought to be able to handle all of these different quad shapes. And then if you can make all four different if you can make all these shapes in one quad, then you can put them together into a full shape. So this should span like the entire gamut. Um, uh, I guess I owe you just a quick. I'll try to make it quick. You know I'm horrible at that, but I'll put a little display here so we can kind of look at what this looks like in practice. So uh, I don't want that one. Yeah, this is fine. That's kind of a representative. Let me zoom in real quick. So all we really care about is the northeast quadrant right there. And so if you look, that would be a null on top and then followed by pin, pin, and then a shape. And so that is indeed a drop pin. And those are not they're not super difficult to make if you're doing them manually, but they're really hard to automate. At least it was for me. So what my scheme was that I wanted to be able to build both operator 0 and operator 1 on the same machine, and it shouldn't matter. So at least on normal mode, I finally got one that I can make anything that pops up in, at least so far, in operator 1 or operator 0 or operator 1 with one make anything machine. And so the first one I made with the quad stack philosophy, I guess, was the one for operator 1, which makes crystals. And so It was pretty simple. You can see these platforms have very little in the way of logic. They're mainly just stackers, some crystallizers and painter. And if you run along to each layer in turn, you'll see that they get a little bit more complicated, but not really. Um, and this works just fine so far, making quad stacks. And then those stacks are assembled. All these are basically identical. They're just making the different four corners all in stacks. And then don't pay too much attention to this because I've already redone it. Essentially, it strips off the scaffolding and then swaps them together into one full shape and then outputs them. Now this one is actually broken right now, which is funny. I just changed over. That's why. So this one is new. It's still flushing out the system. Um, but if we expand it out, the machine won't have any problem making this shape. There's nothing in there that's going to create a problem. It's pretty straightforward. And so, um, operator 0, that's got some pins on it, which is cool. No drop pins though, so that's easily makeable too. Anyhow, I get tangent real bad. See something shiny. Anyway, this guy, I got this working last week, and it took quite a while to get it, but it wasn't too bad. I really just started with an individual platform, expanded it out to four, and then copy and paste, and you have the whole thing with just some simple rotations of the input. Then I went down the rabbit hole of trying to get it to do pins. And I'm here to tell you that I spent an inordinate amount of time and brain power, and I don't have a lot to spare trying to get this thing to work with pins. So what I wound up having to do is because there's so many exceptions for pins that get dropped, they just defy your ability to like make them automate the process. You just have to watch it every step. So what wound up happening is that the layer one stack is pretty straightforward. I mean, there's not much here. You can see that it's basically grab some random shapes, figure out what shape it is, and then either crystallize it or paint it or what have you, and then move on. And then the next one gets a little bit more complicated. Now, this is only possible after the last patch because you were really limited on how many channels you could have. So what I wound up having to do is because the logic got started to get really complicated on this one, not too bad, and then it got worse and worse on every one. Just a quick look ahead. Um, and so what I decided to do, since they're basically giving us, from what I can tell, infinite channels to use, I offloaded the logic onto its own separate platform. And although there's not a lot here, I just needed some scratch pad space because I wasn't exactly sure where I was going with all this. So basically what I did is I just counted up every gate or flow control thing that's on this particular platform, and I just assigned a channel to it. And these channels are kind of my own little naming convention. It's northeast, but I labeled that one, and then two is the platform number, and then I've got this little list where it goes through and tells me what all the things do, trying to leave a little space, just an address space, if you will. Um, and then I created a platform here where these are all the transmitters. So these all transmit, these all receive. These could be anywhere on the map, but it just makes it easier for me to troubleshoot stuff when they're nearby. Um, could I have just made all the little gates go through these holes and put it yes, you could. And in fact, I could stick this underneath and you wouldn't even see it. But I'm still working on this, and I don't want it so cluttered that I can't figure out what's going on. So moving along, level two doesn't have a whole lot to do, but it does need to start checking for dropped pins. So you'll see this logic come up quite often. Um, and essentially this is the best I could figure out. So what I'll do is I'll take the output shape and then compare it against null and compare it against pin. If it's not equal to either one of those, you can see that I've got that set to not equal for those. If it's not equal to either one of those, then it must be a shape or a crystal. Let's just call it a shape for now. And that's how I kind of look at each layer to find out what's on that layer. This guy here, I needed to find out if it was a null, so I just made that equal null, and then I put a not before it gets compared against the pin to find out if it's a shape. So I learned some more about logic while I was doing this. It gets better as I go, but that one If you study a little bit, you'll kind of get the feel for what I'm trying to do there. Down here in the corner, this is just again checking to see what shape, if any, it is, because these first four channels here are the ones that are responsible for opening up the um, gates for the individual shapes coming in. And then moving on, I'm trying to go through this reasonably quickly because I want to get to the meat and potatoes of this in a minute. Layer three gets even more complicated. I need pin pushers, and I need an ability to push the scaffold. I didn't mention that before, but when you're making quads, I kind of came up with this idea where um, you can't just stack a quad. I mean, you can make a quad out of just shapes where it's like square on top of a circle, on top of a sharp, on top of one of those W things. And that's easy to do. But if you've got pins, then the thing will fall down and do weird stuff. Or if it's a crystal, it won't stand on its own. So you have to have some kind of scaffolding around it. So what I did was I grabbed shapes from BFE down here that was conveniently already, I should turn on my little shape asteroid so you can see. It was conveniently already there in a three shape missing the northeast corner, which is exactly what I wanted. So I just shipped them all over here, and each platform has a supply of scaffolds. All right, and so these scaffolds are just shapes that have the northeast corner missing, and so that I can then, whatever shape it happens to be, there is no shape on this one, but that scaffold will progress through. In this case, it's getting crystallized because that shape is a crystal. Um, just the northeast corner is all I'm looking at, and it's crystallizing that. Later on, these will get subdivided and then put together. Hopefully, it may not actually work. Maybe I'll get some by the end of this video. If not, I'll have to go back and find out why it's not working. At any rate, I'm just starting working it with crystals. It worked on the last one, and I'm sure I'll be able to get it to work. Hopefully, I didn't break it by integrating pins, but that's the way the cookie crumbles sometimes. Anyway, let me get back on topic here. The sacrificial layers or the scaffolding that goes in here. Those are two different things. I shouldn't have said them the same. This is the scaffolding that goes in. Sometimes it needs to be pin pushed as well in order to get the proper shape. But even though layer three is a little bit more complicated, um, I had to have a little drop pin detector here, and I'm trying to. These are different configurations that have to be handled on layer three. Just because I'll show you some notes here in a minute if I can take a little excursion, but really even that is just preparatory work for level 4. Now this is why I had to offload all the logic, because I just flat couldn't fit it all on this platform. Maybe if I made a bigger platform I could have, but I wanted to just go ahead and decouple it completely to keep the platforms clean. And so now layer 4 has got 4 separate pin pushers, because it's quite possible that you could have 4 pins in a stack, and or top pins, which is really what this number 4 is used for a lot. And then I've got 3 scaffold pin pushers, because certain drop pin configurations require you to drop a shape that's been pin pushed 3 times on top of an already existing shape in order to get the shape you want. It's bizarre, but that's the way it works out. So having to do that means that I had to go and figure out a way to check against all those exceptions that I mentioned earlier and create special cases for them. The machine builds normal shapes easily. My other ones did that already, but these ones were just defying me because of the complexity of trying to figure out what to do with them. And so in the process of figuring all this out, I discovered some things about logic that maybe some of you computer programmers out there were kind of laughing at me because I seem so um, backwards on some of my logic circuits. But I really got a feel for the gate and the usage of the gate. I wasn't using these gates much at all before, but I found that they provide a lot of flexibility. Number one is that these 4 together are equivalent to an and. In other words, if all 4 of these aren't true, you can have 4 inputs, stack them together like this. If all 4 of these aren't true, then you're not going to get a true a number 1 out of that. All right. But the biggest, and that saves some space a little bit. Now, that in itself is great. We've also got ways to make ors by using these two. I won't call these ors. They're kind of like a cascade. I'll talk about those in just a second. But the bonus of this is that they act like diodes, these little guys, and so you can run um, these output lines to common rails, and it's hard to tell right here because of just everything gets kind of cluttered. But I have rails, common rails for these pin pushing devices and these scaffold pin pushing devices up here, and even the scaffold stacker that's down here. And you can just you could connect things up to them, even though there's and they won't create conflicts, because if only one of these can be kind of true at a time, then it won't backfeed and create, the evil conflict lines that you're used to seeing. And if if you get nothing else out of that little discussion there, I can summarize it like this. If you use a logical operator like an equal sign or an and or an or any of these logic stuff down here, the output of one of these logic signs is either going to be a 1 or a 0. All right. And if that's important because um, I didn't, well, that's fine. Well, you can even kind of see it here because nulls do not act the same as zeros, and that's important. Like, even though this is an and, all right, those are nulls. Even though those nulls are the same, they're not going to create that. Now, if I was to put an equal there, and I don't want to digress too much, but this is kind of important. If I put equal there, then it works. But what I was going to get at is that this is either going to be 0 or 1. No, I have to put something else there just to, I'll put a 1 in there. It's fine. Okay. Now it's either 0. So when this is false, that's a 0. That's not the same as null. So zeros and nulls are not the same. Right now, these are all nulls. And if one of these becomes true and it's connected to these other lines, then that would create a conflict if these were logic gates and they had a 0 coming out because they were false, or a 1 coming out because they're true, and you put a 0 or a 1 on one of these other lines where they're connected, then you get the conflicts. But these don't create conflicts because they're null, so they can be filled up with anything and they don't care. And so it's important to isolate the lines so they don't kind of backfeed. Now, I know this is dense and it's hard to look at, but essentially what these are doing is looking at each one of these um, layers that's imported. These are different slices of the overall shape, and these three lines for this guy indicate this is going to be a pin, that's a shape, and that's a null. All right, and this one is going to be a pin or a null. This is again pin, shape, or null, and then pin, shape. Now, null wasn't used in this configuration, and neither was shape on this guy, and so I didn't need to make them. It saved me a whole it saved me a whole line because I kind of needed that. So I could run all these things just as vertical lines and then just tie into them to see what these different shapes are. And so you can see that some of these are activated and some of these are not, but none of them are active on this particular case because it's not one of these things. But had it been one of these things, then one of these would be lit up, and that would activate certain combinations of pin pushers and scaffolding to make the shape work out correctly. This took me a long time. The first versions were not all that compact and ugly. The first one I made, I think I might still have it over here somewhere. It was really kind of sketch. Um, yeah, this was the first one I made, and boy, here's your OR array using those little gates, which is kind of cool. I don't know if that takes up less than actually using the ORs, but I thought it looked pretty neat, and it actually worked out pretty well. Um, at any rate, this whole thing is disabled, but it's the same basic logic um, that I just showed you a second ago, only it uses logic gates. But the problem with this one is that, again, you can't connect them together because they kind of backfeed, and even though there's nothing going on at this gate, it's still outputting a 0. And if any of these other ones decide to output a 1 because they're true, and there's any connection whatsoever, it just turns the whole thing pink, and that is a bad deal. And so this version doesn't do that, and it allows me to save a tremendous amount of extra wires running around, because even though those wires are kind of skinny, they take up a whole block, and you'll quickly run out of space if you're fast and loose with it. So anyway, now that I've patted myself on the back enough for that, let me just get to the rest of this thing really quick. Um, before I decide to go crazy again. So anyway, um, we've got all of our fourth northeast, northwest, southwest, southeast. Those are the four corners. And then if they're built correctly, then each one of these will have a little, kind of show what's coming out the side or whatever. And really all we're concerned about is that northeast stack. Now, every one of these platforms um, sequences pulls out a northeast stack, but they use the logic here that I described in a previous video to examine the other stack. So all of them put out a northeast stack even though they aren't the same. And then over here, what we do is we rotate them and swap them in order to get the final shape out. And so it looks like it's actually making the correct shape now. I've got my little true text. So just in the time that we've been talking, it took about 9 minutes for this to flush completely. I think the last time I checked. And so that's what we're looking at. And yeah, every once in a while, I'm going to get one of these little glitches here. And I think it's just the game kind of hiccuping a little. But there's a couple of stacker and the swapper area. I think I could optimize the belts a little bit to eliminate those once every so often hitches. But there's a shape it's being compared against. It's putting them out, and it's going to start counting up for me. So it's making crystals, and earlier it made pins. And so until I run across something that it can't make, hey, in the comments, if you've got a shape that can be made in the game and you want me to test it, I'd be more than happy to give it a whirl. Um, I'll put a link to the dropped pin tester in the comments, and you can download it and put it in your game if you want and see if they work. All you got to do with that guy is just hook this line up to whatever's producing the signal that you're listening to for your make anything machine or whatever, and then you can toggle these guys on um, and off. All right, and so you can just test one at a time. Obviously, if you try to test two of them, it ain't gonna work. But if your make anything machine can make quads that have stacks that look like this, then you should not be having any problems with drop pins. Um, and when I say drop pins, it means just pins that have become detached from the shape above them and fallen down to a lower level, which is the most masochistic or sadistic thing that the programmers of this game could do, because it kind of keeps you'll get 99% through this game, be like, I mastered this, and then be like, oh, I didn't. And still, there's combos that I know I can't make with this machine. So, the last time I checked, I'm going to go out on a limb here and say you can actually pin push crystals. And that is one wrinkle that I haven't even tried to mess with now. So, this is still a regular game. I'm pretty sure I can make just about everything that's in the hard game or the insane too, uh, but I haven't tried. But I think this is going to be probably the one kind of make anything machine to rule them all, if you will. Minus the shape providers, it's at with the combiner at the end. We're looking at right around 35,000 buildings and 446 platforms. Could I make this a little smaller? Probably. But I'm not even trying to like optimize it for shape or for size. And those of you who are obsessed with making things tiny, um, I don't think the game engine could take filling up this entire game field. If it could, it would be astounding. I mean, I've only used a small, tiny bit of this game field to make this stuff. So right now, the game's solid. I've got it locked at, well, I thought I had it locked at 30 frames per second. Maybe I don't. Just so that it doesn't create so much heat in my office. I don't like my video card just screaming at me the entire time, so I just run the frame rate at 30 usually. So anyhow, if like I actually invite you to throw me a shape code in the comments, um, and it needs to be makeable in game. Otherwise, I mean, you can create fanciful stuff that you can't actually make with a shape code. But I'll import it, and if it can be made, I'll throw it through the Make Anything machine and see if it can actually make anything. Um, and I'm sure it'll crash on a few different weird combinations of crystals and pins. But for just straight up pins or straight up crystals, I think I got it locked pretty good. So go ahead and throw me a challenge if you want, and I'll see what I can do with it. Thanks for watching.